Hello everyone, welcome to our next lecture. In previous lecture, what we had done that we had completed basic information about program and process. We had picked that what is program. So program is a piece of code, and then we move that once we execute this program, then it is known as process. Means once we load that process into, or once we load that program into our memory, which is our main memory, random access memory, RAM, then it is known as process. So execution of program is process. So today what we are going to see, that is how we represent a process in memory. Yes, we have earlier picked that once we load any program into memory, it is known as process. But when we load any program, how it look like, how it gets stored in memory, and that is the thing which we are going to cover in this lecture, which is known as representation of process in memory. So let's move to today's topic. So what we had done process, let's take one example, that suppose I have written one code in C language, that is abc.c. Generally what it do, it first of all we compile this program and generate its a.out, and in Windows we call it exe file. So after compilation, once a.out or exe file get generated, then this file we move for execution. So once we execute this a.dot file, then how it gets stored in memory. Now this is the structure of uh, any process when get it stored in memory. So it have uh, four variations or four basic portions. One is code section, another one is data section, then there is heap, and there is one stack. Now, if I'll compare with respect to my previous one, that is any process, if I had taken suppose a dot out, then how this particular a dot out will be managed here or will be loaded in this particular format. So what it will do, in code section, the a dot out will be putted. So I'm going to put a dot out here in this code section. Then in data section, all the variables, static variables, global variables, for which uh, program is not going to change value, all those things I am going to put in this data section. So all the static variables I am going to put here. Now we have two more things, heap and stack. So why I am using heap and why I am using stack? I hope you already know what is stack and what is heap. You have already studied all those stuff in data structure. So heap I am going to use for dynamic allocation. As you are aware that once we execute any program, it have uh, lots of things for which it require memory dynamically, like we have used calloc malloc. So once we want dynamic memory allocation, then definitely uh, our process should have certain space where it can store those dynamic values. So for that purpose, uh, process have one area which is known as heap, where all the dynamic allocations have been performed. Now, the next one is stack. Now, why we use stack? Stack is used to hold temporary data such as function parameters, return addresses. If you have recursive calls, then those recursive functions will be stored here so that it can be continuously called. So all those stuff will be managed by stack. So in this manner, the overall process gets stored in memory. So if I want to pick that what is process, if I want to visualize any process, in this way I can visualize that process have several sections like code section where all the code is written, then variable section or data section where static variable and global variable are written. Then there is a heap for dynamic allocation, and there is stack memory is allocated, which help us to provide memory for function parameters, return addresses, etc. So that is our process. And when we talk about process in memory, the more organized, this is the generalized one, that in this manner process loaded into memory. The more specific one is known as PCB, that is process control block, which provide us more information about any process. So, which kind of information we require once we run any process, or at the time of loading into memory, what are different information we required? We had earlier picked that yes, there are four different sections, but if we want to pick that what is actual information we require once any process get executed, so it has so many things like process state, program counter. If I'll go one by one, so the first thing which comes, that is identity of any process, which is known as process ID. So before this process state, definitely each and every process, just like in our class, I need to provide roll number to each and every one, or name to each and every student, so that I can directly identify uniquely that this is the process X and this is the process Y, or this is student X and this is student Y. So for that purpose, what I want the information about the identity of any process, that is known as process ID. So once we have information of process ID, what other information I can have? I can have information that what is the current status of process, whether it is in memory or it is executing in CPU, or it is waiting for certain kind of IO operation, or it got terminated. What is current status of any process? So definitely, if we don't know the status of any process, then how we will process it, or how system will proceed for it. So that's why it is important to have status information. Then definitely, if there is a process, so we know that process have that code section, and code section have lots of instructions. So which instruction should get executed next? And that is given by the program counter. I hope you already know that program counter consists the next uh, instruction which system wants to execute. It's some kind of register which is having value. So definitely we require that information, that what is the next instruction that should get executed, so that our system can efficiently execute it without any delay. Further, definitely we require information that what are the registers which are allocated to that process. If we don't know that X, Y, and Z registers are allocated to process, then might be possible that OS or operating system has allocated the same set of registers to two different processes because of that OS don't have any information about it. So that is the major reason that every process should have information that what are the set of registers which is going to be used by that process. Next, CPU scheduling and information, that which kind of scheduling or has been utilized to execute that process. Now, why we require that? That if X process is executing in terms of any X scheduling and Y process in any Y scheduling, then how to manage those things? That's why process should have information that this is executing with respect to the scheduling algorithm X. Next, memory management information, where our different files are stored. There will be certain list of open files. There will be certain files which could be utilized by those processes. So where they are stored, how to fetch those things, all those things comes under memory management. Then accounting information. Now, what is accounting? Accounting means that if there is one process, then how much amount of time that process has executed into the CPU, how much amount of time that process has invested in input output operations. Now, all those statistics helps operating system to improve itself, and these things are utilized by the researchers and scientists to design new operating system. And in operating system itself, if suppose operating system is saying that this process has not given CPU from a long amount of time, then how operating system will be able to check it on the basis of that accounting information. So all those statistics are managed and stored in the process control block, where all the information of process is written. So what is PCB, process control block, which is having the complete information about process. What is ID of process, state of process, next instruction, what is going to be executed, what are registers allocated to that process, which kind of scheduling algorithm is utilized, what is memory aspect, list of open files, list of closed files, what kind of statistics uh, that process is having, then IO status information, security information, all the necessary information of any process is get stored in PCB, and that PCB is actually loaded into the memory. So we had earlier pegged that in general way we have four different sections. Now here we move into more detail that what is actual information any process poses. Now here is one structure. Once again, it have pointer, process state, process number, which I have told earlier that it is process ID, then a program counter, lots of registers, what is memory limit, what kind of memory is being utilized, what are list of open files, accounting information, security, all those kind of information get stored into PCB. So there is one thing, that what is actually PCB? PCB is a data structure which used to store information about the process. So be careful, because sometimes I think in one gate paper it was asked that uh, which data structure is used to represent process in memory. Once again, I am repeating. The question was quite easy, that which kind of data structure is used to represent any process in memory? And the options was that stack, queue, linked list, all of the above, or PCB. So the answer was, it's PCB, process control block. I know that you guys have not studied this as a data structure earlier, but what is actually data structure? Data structure is a logical combination of memory where you store different things. So it is a logically cohesive unit. And the same thing is here. What we are doing in PCB, we are arranging several variety of information at one place. And logically, we are saying that it is representing one process. And this particular block, which is representing one process, is used to control that process. That's why it is known as PCB, process control block. So I hope that now it is clear that process control block is a data structure which is used to represent process in memory. So that's all we have for today. Today we had picked that what is PCB, process control block, how process get represented in the memory, how process get loaded into memory. So in next class, we will move further and we are going to focus on the second thing which is given here, that is process state. So what is state, how process move from one state to another state? We are going to pick all those stuff into our next class.